Okay, students, so let's come back and look at example 2 now. All right, so it's 2x squared minus 3x equals 8. So the first thing you have to look at is and ask yourself, is this in standard form? And what again is standard form? Remember, it's this form, ax squared plus bx plus c equals 0. So the answer is no, this isn't in standard form because my constant is over here on the other side of the equation. And in order to solve a quadratic equation using the quadratic formula, I have to have it in standard form, which means the whole quadratic is on one side of the equation and 0 is on the other. So we're going to have to subtract 8 from both sides here to get this in standard form. So now we have 2x squared minus 3x minus 8 equals 0. All right, so what's A? A is 2. What's B? Negative 3. And C is negative 8. All right, so we're going to have X equal to the opposite of B. What's the opposite of B? Well, B is negative 3, so opposite of B is going to be positive 3, plus or minus the square root of B squared, negative 3 squared, minus 4 times A, which is 2, and C, which is negative 8, all over 2A, which is 2 times 2. All right, so let's crunch these numbers out. We end up with X equals 3 plus or minus 9. And then we're going to get 4 times 2, which is 8 times 8, which is 64, and I've got an even number of negatives, so that's going to be plus 64 all over 2 times 2, which is 4. All right, so now what do we end up with? We end up with X equaling 3 plus and minus the square root of 73 all over 4. And so you're going to have to use your calculator to calculate this. So first you're going to calculate X equal to 3 plus the square root of 73 all over 4. And my recommendation to you is not to try to key all of this in your calculator at once, because then you'd have to pay attention to where you're putting parentheses, and you'd have to put parentheses around this. What I would recommend is that you find the square root of 73, press enter, add 3, press enter, and then divide by 4. I think it's the safest way to do this. And then you're going to do the same thing, except now it's going to be it's 3 minus the square root of 73 all over 4. And when you do this, they're asking you, they say, now it's not nice and round. The numbers aren't nice and round. They're irrational, in fact, because these are imperfect square roots. You're going to round on the hundredth, the nearest hundredth. And so in this first one, you're going to end up with 2.89. And in this second solution, you're going to end up with a negative 1.39. All right, now I want you to pause this video and go and do the checkpoints for 4, 5, and 6. And then when you're back, press play. Okay, so here is the answer for checkpoint. And here I need to probably shrink this down just a wee bit so you can see it all. All right, so what we have here, x squared plus x equals 1. Again, it's not in standard form, so I've got to subtract 1 from both sides. And now, so I end up with A being 1, B being 1, and C being negative 1. And I'm going to plug all that into my quadratic equation. And then when I do that, I'm going to end up here at the end with x equal to negative 1 plus or minus the square root of 5 all over 2. And when I do the plus first, I'm going to end up with 0.62. And when I do the subtraction second, I'm going to end up with a negative 1.62. Okay, so those are my two solutions. All right, on 5, okay, again, it's not in standard form, and so I have to do a little bit of algebra to get it into standard form. So I'm going to subtract 2x from both sides, and then I'm going to add 3 to both sides. And so this is my new quadratic right here. So A ends up being negative 1, B is negative 2, and C is 3. And if you went in the opposite direction, this would still all work out. Okay, you'd still end up with the same answer. So if you decided instead to add x squared to both sides, you get x squared plus 2x minus 3 equals 0. you would still do the quadratic formula exactly the same way, and you're going to end up in the same place. Okay, so let's say I'm going to put all the stuff in A, B, and C. So here it is, and then I'm going to crunch out the numbers, and I'm going to end up with 2 plus or minus the square root of 16 over negative 2. So I end up with 2 plus or minus 4 all over negative 2. And I get 2 plus 4, which is 6 divided by negative 2, so that's negative 3. And then 2 minus 4, it's a negative 2 divided by negative 2, and that's a positive 1. All right, so those are the two solutions, and then 6. Here's my last one. Okay, so I have 7x squared minus 1 equals 2x. So again, oh gosh, I think I see a mistake here. Okay, yes, it's a minus 2x. Yes, minus 2x. Here we go. Is that right? Yeah. Huh. I got it to work though. Let me just keep going. So I think it's minus 2x minus 1 equals 0. So A is 7. B is negative 2. Okay, that's right. B is negative 2. C is negative 1. All right, so, and I think I got this right. This is going to, well, this should have been this, but it's still not going to affect anything. All right, so I get negative 2 plus or minus the square root of negative 2 all squared minus 4 times 7 times negative 1 all over 2 times 7. And then when I calculate this out, I'm going to end up down here. I'm going to end up with the square root of 32. And I'm going to simplify my radicals. So I know that square root of 32 is the same thing as 16 times 2. So then the square root of 16 is 4 square roots of 2. So I'm going to end up with negative 2 plus or minus 4 square roots of 2 all over 14. Now, the thing I notice, I really have 3 terms here, right? I've got a term here, a term here, and a term here, and they're all even. So I can divide every single one of those terms by 2. And when I do that, I get negative 1 plus or minus. I'm just dividing this by 2, and there it is. So 2 square roots of 2, and then I'm dividing the 14 by 2, and I get 7. And then, again, I'm just going to crunch out those numbers, and there they are. I get negative 1 plus 2 square roots of 2 all over 7, and then x equals negative 1 minus 2 square roots of 2 all over 7. And when I do that, I end up with these values, 0.26 and negative 0.55. Okay, so that's it for the checkpoint. Let's go on to example 3. In example 3, they said find the x-intercepts of the graph. So remember, when we were saying that when we were solving these quadratics, we said that what we were really doing is we're finding where where the x values where y equals 0, correct? So, so if they said they wanted you to find the x-intercepts of this function, well, that's the same thing, right, as me putting a 0 here for y, and then I could just use the quadratic formula and find that. Those are going to be the same thing. So the x-intercepts of this function are going to be where y equals 0. And so using the quadratic formula, it would be an appropriate way for me to find the x-intercepts. So I just set that to 0 plus 4x minus 5, and then I just solve the quadratic just like I normally do. So A is 1, B is 4, and C is negative 5. Okay, so x is going to equal the opposite of b, so that's negative 4 plus or minus square root of b squared, so that's 4 squared, minus 4a, which is 1, and c, which is negative 5, all over 2 times a, and a is 1. Okay, and so now I get x equals negative 4 plus or minus, that's going to be 16, right, plus 20. So that's 36. Okay, 16 plus 20, 36, all over 2. And so x is going to equal negative 4 plus or minus square root of 36 is 6, all over 2. So if I end up with x equaling negative 4 plus 6 divided by 2, I'm going to get negative 4 plus 6 is 2, divided by 2, so that's 1. And then I'm going to get I'm going to do the subtraction. Negative 4 minus 6 divided by 2. And I get negative 10 over 2, and that's going to give me then a negative 5. Now, if you were to graph this function up here, you better see that you're crossing the x-axis at x equal to 1 and x equal to negative 5 on that graph. Okay, and you can look at it in the table too. And if you see where x is 1, the y value better be 0. Where you see x is negative 5, the y value is going to be 0 because that's what you just found out. You just found out where y is equal to 0. Those are the x-intercepts of the graph.